Okay, in the last class I dealt with the FPGA, it is Field Programmable Gate Array. Okay, I started with the what is meant by Field Programmable Gate Array. It is the integrated circuit that contains 64 to 1000 bits identical logical cells that can be viewed as a standard component. Okay, this is an basic thing in the FPGA. As in the CPLD, only it is the entire thing purely contain either NAND and or plan, but that is not the case in the FPGA architecture. FPGA architecture consists of the three basic blocks. They are called the configurable logical block, CLB, simply called LB logical block, or second is configurable IO block and programmable interconnect. Okay, in some vendor, some FPGA architecture, they may consist of additional blocks also, that is ALU, memory and decoder may be available. Depending on the different FPGAs, they may available ALU, memory and decoder. General things are three basic blocks. It consists of three basic blocks. One is called configurable logical block, CLB, second is configurable IO block, and third is programmable interconnect. Okay, they are the two basic types of the programmable elements for the FPGA. There are two basic elements, basic types of the programmable elements of the FPGA. They are called the anti-RAM and anti-fuse. Okay, each logical block in the FPGA has a small number of input and output, as well as a lookup table. We will see that what is today's class. We will go in detail to the what is LUT. LUT is called the lookup table. It is the most commonly used type of the logical block used within the FPGA. In the part of the logical block, that is configurable logical block, we are going to use a one term called LUT. LUT is called the lookup table. Okay. Just wait. Next, there are three types. They are called the one is anti-fuse, and that anti-fuse is called the one-time programming. This is the architecture, basic architecture of the FPGA. It consists of LB logical block and programmable interconnect and IO input-output block. Okay, here every FPGA consists of the following elements. One is called configurable logical block, CLB, configurable input-output block, and two-layer metal network of vertical and horizontal lines for interconnecting the CLBs, which are called the programmable interconnect. It is called the finally third is called the programmable interconnect. What is meant programmable interconnect? They are the vertical line and horizontal line. A vertical line and the horizontal line. Okay, and the straight and the just say the 4x4 matrix, 4 rows and 4 columns, vertical line and horizontal. They are the interconnecting the line, that is to be programmable interconnect. Next, LCA is called logical cell array. Xenix logical. It is a basic basic thing. They have the initial design thing. Xenix in 1985 for their FPGA device. It is the most likely property and trademark property of the LISP implementer of the FPGA device. Okay, this is a basic block. Basic entire basic is based on the Xenix LCA architecture only. Consists of the three major components. Almost all the FPGA, these three major components are present. They are called the configurable logical block, input output block, and programmable interconnect. In addition, configurable memory is also used to hold the configuration program bit, which controls the configuration of the CLR, M and IOB and interconnect. Okay, just a memory also present. Next is in LCA architecture, that basic LCA architecture, LCA architecture, the core of the LCA is the matrix of identical configurable logical block CLB. Each configurable logical block contain a programmable combination logic and storage element. In the CLB, the basic thing is called the one is combinational logic, second is storage element. Okay, now this is the basic block. We can represent in the another way. It is one of the another way of the representing FPGA architecture. The peripheral of the logical cell array is made up of the user programmable input-output logic. Now finally, the peripheral nothing but input-output pins, input-output lines. They have to be connected to the external device, external world. Each block can be programmed independently to an input, an output, or bidirectional pin with 3-state control. The input can be programmed to the recognized as the TTL or the CMOS threshold. Each IOB also includes the flip-flop that can be used to buffer a input and output. Here the input in the IO pin, it acts as a pin. It is used as generally initially they are designed with an flip-flop. Later on they are extended with all the flip-flop, that is SR and JK and T flip-flop. Okay, the programmable interconnect. In the last class up to this I have been covered from this. Okay, programmable interconnect. What is meant by programmable interconnect? The FPGA, 3 types of metal resources are provided to fulfill the various interconnect network requirements. Okay, this is a programmable interconnect. There are the 3 basic types. They are called the general purpose interconnect. First one is called the general purpose interconnect. Second is called the direct connection. Third is the long line, that is the multiplexed buses and wide AND gate. Okay, there are 3 basic types of the programmable interconnect. One is general purpose, second is direct, and third is long line. What is general purpose? In the general purpose, it consists of the 5 horizontal and 5 vertical metal segment located between the rows and columns of the logic and IOBs. It is the lines, total 5 vertical lines and 5 horizontal lines. 5 vertical and 5 horizontal lines are present. They have been interconnected. They have fixed in between the IO as well as between the CLB. They are located. They are the 5 lines, vertical lines and 5 horizontal lines are metal lines. They are located. They are the rows and columns in between the CLB and IO. Each segment is the height and width of the logical block. It is same as the width and the height as similar to the logical block one. Okay. The switching matrix joins the ends of these switching matrix. That switch has to on or off through a program only. We are connecting the switching matrix joins the ends of these segments and allows the programmer the segments and allow program interconnection between these metal grids segments of adjacent rows and columns. Okay, we'll see one diagram. From that diagram we can understand that what are the rows and what are the columns, how many lines are there. Total 5 lines are there. Okay, in this 5 lines, one is there switching matrix. The switching matrix, which line has to connect it to the which one. For example, say here I have a line 1, say CLB1, CLB2, CLB3 and 4, 5, 6 CLBs are there. From this they are used a 2 switching matrix. Total 5 lines, vertical lines and 5 horizontal lines. 5 vertical and 5 horizontal lines are there. They have been connected through the switching matrix. Okay, First, I want to communicate. Just there is a communication. I want to communicate. I have to connect these things from the CLB1 to the 5, 4, okay, 2. For that, I have used a line 2 from the switching matrix. The line 2 of the CLB4 have been connected, as well as here one more line. They have from the switching matrix, say switching matrix 1 and switching matrix 2. This switching matrix 1 have connected to the line 4 to the CLB. Okay, we can shift, we can select the any line depending on the availability of that free line. Okay, once I have connected, I have been programmed, that path has been decided, path has been dedicated. Okay, this line, say from the CLB1, it has been communicated, it has been physically connected to this line, as well as from this it has been physically connected to the CLB5, and same line is communicated to the CLB2. The same line is communicated to the here also. One more line, the indicate, right, the indication here, the arrow marks indicates that here it is an input, it is for this it is the input line to the CLB5. From the CLB1 it is the output is indicated outside, it is an output line, it is indication, and this is an input line, it is indication to the CLB5, CLB4 and CLB2. As well as the thing is from this line, from the CLB5, it is the output line. They are the connected through this line. Okay. Similarly, for example, for the switching matrix 2, it is connected to the logical block 3, and this logical block 3, it is an output line. Okay. This line is switching through the switching matrix. It is connected to the communicated to the here. Okay. The thing the user has to define that. Is that is an input line or the output line to the CLB. There are a number of inputs and output lines are there. A number of input and output lines are inside the CLB. We have to connect to the particular selected CLB, and we have to define that this line is input or output through a programming means only. This switching matrix, it is switches to the, here say I have 5 lines. Among the 5 lines, which line I have to connect, which line I have to communicate it through the, I have to pass the signal. Okay, it is the first one. It is called the general purpose interconnection. It is the first type, it is called general purpose interconnection. Second is the direct connection. Okay, here that in the general purpose switching, the switches of any unprogrammed devices are all non-conducted. Okay, that is unprogrammed. Programmed only they have conducting lines. Unprogrammed they are not been conducting lines. They are the device. The switches of an unprogrammed device are all non-conducting. Okay, the connections through the switch matrix may be established by the automatic routing or by selecting the desired pair of a matrix pins to be connected or disconnected. That switching is only connecting. That switch has to connect or disconnect. Here we have things called the, one is called the automatic routing, or by selecting a desired pair of the matrix pins. Okay, we have different types of the routing methods are there. We have the different methods of the routings are there. One is called the automatic, or by selecting the desired. Okay, next is the interconnect buffers are available to the propagate signals in either directions on a given general interconnect segment. Okay, there is a buffer. That buffer we can use this pair, either it can input or the output. The buffer operation is we are storing the data. We can extract data from that, or we can send the data from that. The interconnect buffers are available to propagate signals in either directions on a given given general interconnect segment. On this segment we can send that things. These bidirectional that is BID buffer also found adjacent to the switching matrix above and to the height. Okay, it is about the general purpose interconnection. Second is for the direct interconnection. Direct interconnection provides the most efficient implementation of the network between the adjacent CLBs and IO blocks. Generally, this interconnections purely it is interconnect between the IO block and CLB. The interconnection matrix, interconnection switch is purely it is interconnecting between the IO block as well as the CLB. The signal routing from the block to block, from each block to block using the direct interconnect exhibits minimum interconnection propagation and use no general interconnection resources. Okay, it is generally dedicated. Say here directly connection. These are the lines, they are the general purpose lines are available, but they are the dedicated directly. We have been communicated directly from the one CLB to the another CLB. Directly a connection path, extra line has been established in the direction connection. Okay, direct interconnect should be used to maximize the speed of the high performance portion of the logic. It is for the high performance purpose. Where logic block are the adjacent to the IO block, direct connect is provide alternative to the IOB input, I as well as output on all four edges of the die. Okay, it is all the edges we can connect directly. The right edge provides the additional direct connection from the CLB output to the adjacent IOBs. Generally, it is directly connected simply. Okay, it is extra line, extra signal, directly connection from one CLB to another CLB or from the IOB to the CLBs. Next is long line. The long line bypass the switch matrix and are intended primarily for signals that must travel a long distance. It is for the long line for the long distance, and most have a minimum scale among the multiple destinations. When you have multiple destinations, then we are going to use a long line. Long line run vertically and horizontally the height and width of the connect area. It is same as the height and width of the CLB simply. Each interconnection column has a 3 vertical long lines and each interconnection rows has 2 horizontal long lines. One is called the 3 vertical long line and 2 horizontal long lines. Just see here, we have a 3 vertical and 2 horizontal lines. These are the horizontal lines, 3 vertical lines. It is for the long line. It is the same as the die. Okay, long line, 3 vertical, 2 horizontal. Each block consists of the, say here on the first above 2 lines, 2 horizontal lines and 3 vertical lines. Okay, the thing is the entire path is available. Through a program we can connect that. 2 additional long lines are located adjacent to the other set of the switching matrix. 2 additional long lines are located adjacent to the outer set of the switching matrix. Okay, the long line can be driven by the logical block or the IOB output on a column by column base. Okay, it is column by column base. It is not the row base. Okay, this capability provides a common low sweep control or a clock line within each column of the logical block. Isolated buffers are provided at each input to the long line and are enabled automatically by the development system when a connection is made. Just if you remember that 3 vertical lines and 2 horizontal lines in the long line connection. Okay, next is a technology mapping. Next topic, next thing called the technology mapping is a logical synthesis tasks that are directly concerned with the selecting the circuit elements used to implement the optimized circuit. Okay, selecting a particular elements from some location, from driving some location. A previous approach is to the technology mapping. Have a focus on the using circuit elements for the limited set of the simple gates. However, such approach are the appropriate for the complex logic blocks where each logical block can implement a large number of the function. Okay, thing is that separate logical blocks are there. Each logical block is defined a some function. Whenever we require, we extract that function for designing the entire project. Okay, one of that is called the library based technology mapping. First type is called the library based technology mapping. In the library based technology mapping, gates or components are selected from the technology library to implement a circuit. Okay, say I have to define a full adder. For the full adder, I need a XOR gate, 2 XOR gates, and the 3 NAND gates, 5 and NAND gates are required. I have in the library already a defined NAND gate function and XOR function, exclusive OR function. I have to extract that component, I have to interconnect that component to give a exact output of that full adder. Simply from the library, already a predefined operation, predefined components, predefined gates are there. Simply selecting from that library to implement a circuit. That is called the library based technology mapping. Okay, hence it is referred to as the library building. So this method generates a technology mapping for a given Boolean function network using the characterized cell library with the objective of the cost optimization and delay optimization. The basic aim behind is I have to reduce the cost of the design as well as the delay. The basic thing is design time and second is delay operation. Okay, when we have a already cost optimization. Cost optimization is if you have a predefined logic things, I have to extract that delay time. The design time also be reduces. Once the design time reduces, the cost also being reduces. Okay, now most of this method, the set of the available circuit elements is represented as a library of the functions, and the construction of the optimized circuit is divided into 3 sub-programs. One is called the decomposition, second is called matching, and third is called covering. Okay, the original network is first decomposed into the canonical representation. This decomposition generates that there will be a number of nodes in the network that are too large to be implemented by the library elements, provide the library includes the NAND gate that reaches the fan-in limits. Okay, in the next class I will go for these extensions. What is meant by decomposition, what is meant by, basically we need thing called LUT. What is the LUT based technology? Lookup table, LUT, lookup table circuit. What is meant by that? What are the key terms? What is the thing called the LUT itself? LUT based technology. Okay, we will go in detail to the LUT based mapping only, technology mapping only. Next class I will explain about these things. Finally, third type is called a multiplexer based technology mapping. There are 3 things. One is called multiplex based, second is called the lookup based, third is called library based. There are the 3 mapping technologies. Okay, in the FPGA there are 3 mapping technology. One is called library based technology, second is called LUT based, lookup table based technology, third is called multiplexer based technology mapping. We'll go for these three things next class. Next class probably I may not take tomorrow's class. I need to go to the college for the MAC work. What are the programming technologies? Already I explained two things. One is called SRAM and flash programming and anti-fuse. Okay. You may go for in detail to the what is static RAM based program technology and flash programming technology is EEPROM and anti-fuse based program technology. What meant by the static RAM cell? What are the different terms used in that? And flash programming technology. This is flash programming technology is an electrically erasable program read-only memory. Finally, anti-fuse programming technology is an alternative to the static RAM. The floating gate based technology is an anti-fuse programming technology. What is meant by floating technology? We'll see that things. This comparison of these three technologies is static RAM, anti-fuse, EEPROM. Okay. One Xilinx XC3000 FPGA device. What are the things are there in that device? What is the architecture of that? I may not go in detail to these things. What is meant by configurable logical block? What are there in the configurable logical block? XC3000 CLB block, programmable interconnection. What is the series XC4000? What is the block diagram of that thing? Series structure of the comparison. Finally, the next class I will conclude these things. Design flow and omega into this. Finally, applications part only I will go in the next class. Applications of the FPGA. It is one of the important question for the examination point of view. Applications of an FPGA.